Hi everyone, welcome to my YouTube channel. I am Lisha, studying in Sri Venkateswara College of Engineering. I am here to explain about the topic debugging using data structure from the title Data Structure and Applications, and its code is BCS 304 and it's guided by Archana ma'am. Introduction. Debugging code can be tedious and airborne, requiring programmers to manually trace execution and hypotheses about faults. This process can be time consuming and may introduce new bugs. While various tools exist for bug localization, manual fix can inadvertently create future issues. We propose a constraint-based technique for automatic program repair that reduces the debugging burden by suggesting light fix. Our approach generates corrupted program states from buggy code, repair these states using data structure repair tool and synthesis, representing possible fixes. To enhance confidence in these repairs, we incorporate scope-bound testing such as Current framework, reduce tools like Zui focus on repairing complex data structured, maintain execution. We explore a non application of this repair techniques for automated debugging, translation, repair, action, and force or fix. Our conclusions are threefold: introducing data structure repair as a basis for automated debugging, demonstrating the feasibility of our technique with the illustrative example, identifying fault scenarios that affect debugging techniques must address. While significant research on automated debugging exists, our work is fast and leverage data structure repair for fixing fault code and generating debug suggestion for complex data structure. Background: Ruby is an automatic framework of repairing corrupted data structure on the fly. GIF corrupted structure on a Repo-OK method that defines integrated constraint. Dewey systematically views the structure field to satisfy these constraints. It locks the repair actions as a tuple, where each tuple is represented as modification field of object. For example, in repairing corrupted doubly linked list, Suzy first invokes repo-OK to identify the fault. If repo-OK returns false, Suzy mutes the last accessed file by setting it first null, secondly previously visited node, third new node. If the first mutation to null fails, it tries to provide visit and then moves on to the new node. Once a valid fix is found, like charging to the previous field to node E0 to E1, Zuzi logs the successful repair. To enhance repair effectively, Zuzi aims to preserve data reachability. If the repair structure has fewer data than the original GUI attempts, additional repairs to restore reachability. The next section will be describe how to translate these repairs action to code statement for effective debugging suggestion. Now, here is an example program. Java statement new entry dot next previous is equal to new entry. This statement serves as abstract repair code and provides a debugging suggestion. Append the sequence at the tail of the execution path just before the returning statement. While this suggestion is likely to fix the specific anonymous execution, it does so by undoing the anonymous field functions of execution. Technically, this may qualify a bug fix. However, this use may have to go through a tedious process of determining what fault each assignment statement is fixing. Ideally, we would like to mechanically determine where the anonymous mutations are located in the fault code to be replaced with them with the paired mutations. We envision an algorithm that takes as input the false. The false method input exhibits the anonymous output. The sequence of assignment statements that represent repair actions submit repair statement and corresponding sequence portrait. Repair actions institutionally the algorithm determines for each repair statement where the place in the fault method. There are two placement probabilities. First, replace an existing statement with it, or second, insert it in execution path as a new statement. The algorithm first tries to find an existing statement replacement, but if it fails to find such a statement, it inserts it a new statement. To institute the fault method, add before for the repair statement new entry dot next dot previous is equal to new entry, and the corresponding repair action e naught previously e1. Statement line 46 is one replace since it assigns the same object field as a repair action. Constraint-based automatic debugging initial thoughts and false scenarios. These scenarios describe a program repair technique for Java method that handle structurally complex data and must maintain structural inheritance. The technique involves three core steps. First, utilizing of this shelf data structure repair, like UZ, to transform enormous outputs into valid program pages, abstracting the constraint repair action into the sequence of Java statements using variable visible within the method's code. Third one, theoretically determining where the insert the generated statements within the method. The text outline various fault scenarios that are effective. Automatically debugging technique must be addressed. A straight line code missing assignment. An example is a add last method which calls the fault add before the method that mistakenly an, an assignment leading incorrect output. B. Code with loop fault outside the loop body. In this case, a method as used looks to locate entries and calls anonymous and add before method which performs destruction updates. This example highlights the different types of faults that previously discussed. This section will continue by detailing and enhance and implementation of add before. Conclusion. This paper introduced a constraint-based data structure repair technique as a foundation for automated debugging. An illustrated example demonstrated its feasibility, highlights key fault scenarios that affect debugging must address. To enhance confidence it, in the correctness of repair, the technique integrates the forward frame for systematically testing, which can generate valid inputs and various verify outputs using repo OK. Bugs identified by correct can inform their repair process, allowing the iterative debugging of program within multiple faults. Beyond automatic debugging, the proposed algorithm could enable level applications such as optimized data structure repair by injection abstraction or repair code into fault method program could set repair the fly significance, speeding up process compared to run Suzy rapidly. Another potential application involve programming by sketching can innovate field assignment to repair later. Future works will focus on explaining the technique of to address a wide range of faults and exploring various invocation applications. Thank you for watching my video. Please like, share, and subscribe to my channel.